So this is our day 5. Okay, so we are going to this consumer group. So this is our Kafka. Okay, this is our producer, which is writing the messages to broker, and these are the consumer inside the consumer group. And these consumers are reading the data from the Kafka broker. And then what will happen? These consumers are going to write the data to a data center. So basically, I'm going to explain you what is consumer group. Okay. So do you know what is how we achieve the scalability in Kafka? Any idea? Any wild guess?
Increasing and decreasing the number of systems.
Yeah, but ultimately increasing the number of system, what it will increase?
Brokers will increase, like Kafka brokers will increase.
Right, but again, same question. Increasing the broker, what it will increase exactly? So okay, let me just let you know. So basically, we are going to increase the number of partitions.
Yeah, partition will be increased.
Ultimately, number of brokers will increase the number of partitions, because more brokers we will have, more capacity we will have to host the partitions. Okay, so that is how we can write more and more data. So whenever someone says if the number of the amount of data is increasing, okay, how you will handle that much of data in that single topic? So your answer,
the partition.
Yeah, your answer will be we will increase the number of partition in the topic. We will never create a new topic. Topic will remain one only. Just that we have to increase the capacity of that topic. And how the capacity will increase?
By increasing the
number of partitions. Yes. Yes. So the capacity of topic is increased now. So that is one way to achieve the scalability. Another way, now this way of increasing the partition, this will increase the capacity in terms of producer. Okay, producer will be easily able to put the data in the Kafka topic, because now the number of partitions are increased. Okay, but from the partitions are increased. Okay, but from the consumer perspective, it is still a problem. Okay, so suppose producers are increasing, so you are increasing number of partitions. But if consumers are not able to read the partition, or consumers are not able to read that much of data, then how you will increase that thing? Okay, how you will increase the capability of the consumption? That is the big question. So then, in that case, consumer group comes into the picture. Okay, so in consumer group, as the name suggests, instead of one consumer, you will add one more consumer, or you will increase two consumer, or you will add some 5-6 consumers. So collectively, those consumers will be able to consume the data, which is coming very rapidly, very fast. Okay, from those partitions. Okay, I am giving you the example of producer and consumer problem. Like simple thing, you are your application is generating something, and there are some consumers which has to consume the data in a particular time. Like in 15 minutes, they need to consume every data, all data. Okay, so 15 minutes is the timeline to consume that data. Otherwise, that data will become stale. So to achieve that, obviously, we need to increase the number of consumers. Okay, so what we will do is we will add more and more consumers, and will belong to the same same consuming application. So we have to assign a consumer group to that particular those set of consumers. Okay. So this is how we create the consumer group. So in single line, I can say all the consumers of a consumer group belongs to a same application. Okay, and they will read the data from the same partition, but same topic, but they will not read the data from same partition. Okay, why we are increasing the number of consumer? Because there are huge number of partitions. But consumer, if we will create only one, then that single consumer cannot read the data from all the partitions. Each consumer will be assigned at least one partition. Okay, so for example, if there are 3 brokers and there is one topic and there are 4 partitions. Okay, and you have created 4 consumers. Then each partition will be assigned to one consumer.
Okay.
Clear? Till here everything is clear, or any doubt?
No, it's clear.
Okay. Now, suppose if consumers are 4 only, but partitions are 8, then what will happen? Each consumer will be assigned 2 partitions.
Yeah.
Clear?
Yes.
Now, if suppose partitions are 5 and consumers are 6, then if partitions are 5 and consumers are 6, then obviously one consumer will be idle.
Yeah.
Right? We will assign only one partition to each consumer, still one consumer will be left.
Yes.
So that will become idle. So there is a rule, you can never create consumers more than the number of partitions.
Okay.
Okay. Otherwise that capacity will be waste. That consumer will be of no use. So 6 partitions, it means at least 6 consumers should be there, not more than 6. Okay. Obviously, if there are more partition and less consumer, then you can assign more than one partition to a single consumer. Am I making sense?
Yes, yes.
Okay. So this is very simple. No 2 consumer will read the same partition. That more than one partition to a single consumer. Am I making sense?
Yes, yes.
Okay. So this is very simple. No 2 consumer will read the same partition. That is the first rule. Okay. Inside a single consumer group, no 2 consumers can read the same partition. But yeah, of course, consumers from different consumer groups can read the same partition. That is possible. Okay.
2 consumers can read the data from the same partitions, but it should be under the same consumer group.
I'm repeating again. 2 consumers from the same consumer group cannot read the same partition.
Okay.
But so one consumer from this, another consumer from another group, they both can read the data from the same partition. That is possible. But if you say consumer 1 from this consumer group and consumer 2 from the same consumer group, these 2 consumers cannot read the data from the same partition. Okay, because that will be kind of duplicate thing, because all these consumer from this consumer group are part of the same family.
Yes, yes.
Okay, so unnecessary, if 2 people will do the same thing, it is of no use. Okay, but consumers from two different consumer group, they are not part of same family. Okay, they both are for different purpose. So obviously they can read the same partition. Okay, they can read the same partition. Okay. So now you understood what is the role of consumer group. Consumer group is created to allot more than one consumers and group them together so that they can read the data for the same purpose. If purpose is different, then group will be different. Okay, so here our purpose is they all are reading the data and sending to the data center. This is our one purpose. Okay, but my other purpose could be read the data and convert it into some other form and then send it to some other channel. That is another purpose. So I will create another consumer group. Okay, so that is the whole idea about this consumer group, and we can consumer group. One way to achieve scalability is by increasing the number of partitions. Another way is to increasing the number of consumers and allocating them to a consumer group.
Okay.
Is it clear?
Yes, the Kafka is scalable only because of it has consumer groups and partitions.
Exactly. Yes. And these two are very important concepts. If someone asks you, is it possible two consumers from same consumer group can read the partition, can read the same partition? Your answer will be no. Okay. Another question could be, is it possible to have more consumer than the number of partition? Your answer will be no. Your answer will be no.
Sorry, you please repeat.
Yeah. Is it possible to have more consumer than the number of partitions?
No. Yeah.
Yeah. Is it possible to have more partition than the consumer?
Yes, we can.
Yes. Okay. So I think now you are clear.
Yeah.
So
Like when we studied, when we went through about the decoupling process, like we came to know that the producer and consumers are independent, right? So consumer don't want to wait.
Yes.
It can take its own time to
Yes.
read the data. So in several cases, we need to create this consumer group.
Yes, obviously. Consumer group is required whenever you are having more than one consumers. If there is only single consumer, then you don't have to create any consumer group. As soon as you create two consumers, then you will create a consumer group. As soon as those that consumer group is created, then those two consumers cannot read the same partition.
Yeah.
Okay. And decoupling will always be there. We know that because producers and consumer, those are independent. They don't know anything about each other. Producer is producing the data to the Kafka, but producer is not saying that you only read it. No one can else read this data. Anyone is free to read the Kafka data, whoever wants to read. Okay. 10 different people from 10 different places can come and they can read the data. Okay. That is the whole purpose of Kafka.
Yeah.
Let's go ahead. I'm going to again repeat. It is a set of consumers which cooperate to consume data from the same topic. Any confusion in this?
No.
Second point is the partitions of the topics are divided among the consumer in the group. This is also clear?
Yes.
No two consumers from a consumer group can read data from same partition. This is also clear.
Yeah.
Now, in the previous session, I told you that whenever you want to send a data to a particular partition, you create a key and always send that same key to the message, and the data will go to the same partition. Okay. If you are not sending any key, only you are sending value, then your data will be going to the partitions in the round robin fashion.
Round robin, yeah.
Right. So now it is always better to send the data with a key if you have a situation, something like where you need the order processing of message in a particular order. Okay, so we know that in a partition, the data is always ordered. First data will be at the 0th position, second data will be at first position, third data will be at second position, and like that. So in a partition, data is always ordered, and if you want the data to be sent in a particular order, so always send it to the same partition. Okay, if you send it to different partitions, so your first message will go to the first partition, second message will go to the second partition, and then there will not be any ordering maintained. It will go to the second partition, and then there will not be any ordering maintained. Correct? And now, if suppose you want to send the data to a particular partition, then you will decide a key. Okay, so key could be anything, but it is better if you want to give it a name, something related with the ID of the consumer. Okay, suppose my consumer name is my consumer name could be anything like what can I say? Suppose some consumer is reading my data from the Kafka and its name is, for example, bookstore, ABC bookstore. Okay, so where you send it to particular partition, so you give it a name ABC bookstore. Okay, it could be any name. So whenever you will send the data, always use the same key, ABC bookstore. So obviously your data will go to the same partition, and on the other side, like right hand side, consumer know that my data is coming in this partition, and they can read it from that partition only. So this is how you can process the data in a sequence, in a particular order. So now the whole idea is how this partition number is calculated, because we know partition number is starting from 0. Partition number 0, partition number 1, partition number 2, like that. But your key, message key is very big. So how that number is converted, how that converted into number, that is the question. So first step is you will apply the hash function to your message key. Okay. So that hash function, or what it will do, hash function will convert your key into a number, because hash is nothing but a number. Okay. So you apply a hash function to it, and then you will get a number. Second step will be you divide that number to the number of partitions. Okay, that is called, sometimes we call it in the mathematic terms, mod. So you find the mod of that number, or you can say remainder of that number, by dividing it with the number of partitions. Then finally, whatever result you are getting, that will be your partition number. Okay, if result you are getting, that will be your partition number. Okay, if the number is fully divided, then there will not be any remainder, so remainder will be 0. It means your partition number is 0. Okay, if the remainder you are getting is 1, then your partition number will be 1. If the remainder which you are getting is 2, then your partition number is 2. Got it?
Okay.
So in the last line, I have given the formula, hash function. You have to pass the key inside that hash function. It will give you a number, and then you do the mod operation by dividing it the number of partitions. So that is modulus operator. Then you will get the partition number. So that's it. This is how it is done internally. But you have to just know this, just for the sake of knowledge. No one is going to give you the calculation or going to ask you this thing. Just remember that this is how it is done internally. Kafka will do this. You don't have to do it.
Okay.
Okay. You just have to give a key to the Kafka. It will automatically give you the partition number.
Okay.
Clear? Let's go ahead. So in the previous topic, I told you that this is how the ordering will happen if you are not sending any key. So in this picture, you can see this is partition 0, this is partition 1, this is partition 2. Okay. Now you are sending the message. So obviously the first message will go to the partition 1 if you are not providing any key. Second message will go to the partition 2 if you are not providing any key. Second message will go to the partition 2. Third message will be go to partition 3. And then fourth message will again come here. Right? Because this is round robin happening because you are not passing any key. So round robin algorithm is being followed here. Now, second, if you are giving the key, then obviously all your messages will go to the same partition. So suppose your key is XYZ. So all the message with the key XYZ, those will go to partition 0. 1, 2, 3. For all these messages, the key is XYZ. So that's why these messages all are coming in this partition 0. Now, for second type of key, you are giving something like ABC. So it is going to partition number 1.
Yes.
Basically, here ordering is happening. 1, 2, 3 is coming here. 4, 5, 6 is coming somewhere here. 7, 8, 9 will be coming here. Now here, when 4, 5 is coming in black and then this 6 is going here, it means the key was different. Key was given differently. That's why this message came here. Okay. If key was same, then 6 would have come here. So that's why here there is no order. 8 and 9 both are coming in the same order because these two are having the same key. Okay. So this picture showing the some kind of shapes, so that those shapes are nothing but those are representing the keys which you are sending, nothing else. Let's go ahead.
Yes. Yes. Sure.
Now we will discuss about the Kafka working scenarios. What are the scenarios where Kafka will be operating? So one is workflow for publish, subscribe messaging. And another one is workflow for queue messaging or consumer group. Okay. So now we are going to discuss these two scenarios in deep. What will be the steps, how the data will be consumed. Okay. So let's go ahead. Scalability, we have seen how the scalability is achieved using partition and consumer group. That is fine. So I think this slide should be previous coming before this slide. There is some ordering. I will change it. So first is fine. So I think this slide should be previous coming before this slide. There is some ordering. I will change it. So first scenario of this Kafka working scenario, pub/sub messaging, we are going to discuss. So how this pub/sub messaging will work? What is the workflow? So producers will send messages to a topic at regular interval. Then step 2 will be Kafka broker stores all messages in the partitions configured for that particular topic. It ensures the messages are equally shared between partitions. If the producer sends 2 messages, there are 2 partitions. Kafka will store 1 message in first partition and the second message in the second partition. Okay. So this we are saying in case of there is no key. By default, I'm assuming we are sending data without any key. To read this data, consumer has to subscribe to the topic. Then once the consumer subscribes to a topic, Kafka will provide the current offset of the topic to the consumer. And Kafka will also save the offset in the zookeeper. Okay. So offset you know already, Jagdish, right?
Yeah, sequential number. Data.
Yeah, each message in the partition has the offset, and that offset starts with 0. First message will be at offset 0, second message will be offset 1, and like that. So whenever first time consumer want to read any message from the Kafka topic, so then what will happen? Kafka will give you the offset of the first message, and then it will store that offset in the zookeeper also. So second time, what will happen? From where we need to read the next message, that we can easily identify by checking the offset from the zookeeper. Okay, so till here it is clear?
Yes.
Now, consumer will start requesting the data to the Kafka after a regular interval. It could be like 100 milliseconds, for example. Okay, so after 100 milliseconds, it will ask for a new message. Give me a new message. Then after 100 milliseconds, it will again ask, give me a new message. So like that, it will happen. It will happen even faster, but just for example, I have mentioned 100 milliseconds. It will be microseconds actually. Kafka is very fast. So consumers also has to be very fast. Okay. Now, once Kafka receives the message from producer, it forwards these messages to the consumers. So in real time, generally there shouldn't be any delay between producer and consumer if it is live streaming, correct? So currently Cricket World Cup is going on, and Cricket World Cup is obviously something which is live happening in the cricket ground. So there shouldn't be any delay whenever we are watching any match from our TV or through any platform. So as soon as producer is producing the data, right, and the producer will be the broadcasters who are live capturing the video and they are sending it to Kafka, right? So this is what point number 6 says. Once Kafka receives the message from producers, it forwards these messages to consumer. Now, consumer will receive the message and process it. So, processing could be anything. Sometimes processing means simply displaying the data, and sometimes processing means you will make some changes in that data so that it becomes useful for the user before you actually show it. Right? So
like reports and all.
Like
generating reports.
Correct. Yes. Because generally data will come in some format, JSON format. Data, if you directly show to the user, it will not be useful. They will not be able to understand anything. So, and sometimes data will be coming directly encrypted also from the producer. So you have to decrypt it. Right? Encryption, decryption, right?
Yes.
So for security reasons, sometimes producer directly encrypt the data, and then at consumer side, you have to decrypt it before you can utilize that data. So that is what the processing means. But processing has many meanings. It depends from consumer. It varies from consumer to consumer. Okay, so processing has very vast meaning. Processing could be anything. You are performing some operation on the data before you actually use it. That is the meaning of processing. Next point is once the messages are processed, consumer will send an acknowledgement to the. Next point is once the messages are processed, consumer will send an acknowledgement to the Kafka broker. So obviously now, first message you have consumed, you are ready to consume the next message. So you have to acknowledge the Kafka that yes, I am done with first message, give me the second message. Okay. So while doing the acknowledgement, you will tell the Kafka which offset you have already consumed. So I consumed just now 0 offset. So I will tell 1. So 1 means now I'm expecting the data from the offset number 1. So now the broker will give me the next data. Again, I'll consume the offset number 1 and then I'll say 2. And then broker will give me the third data, which is at offset 2. So this process goes on. Kafka receives an acknowledgement. It changes the offset to the new value and updates it in the zookeeper. Okay. So now the new value will become 1 because previous value was 0. So there's one value will be updated in the zookeeper. Since offsets are maintained in zookeeper, the consumer can read next message correctly even during server outages. So this last thing is very important. Why we are storing this offset into the zookeeper? There is a meaning. There is a importance of it. Suppose you are reading the data continuously and sometimes what happens is power goes off and your consumer goes down. Okay. So again, you cannot start reading the data from the beginning, right? Because you have already consumed so many things. Why you will consume the same data again and again? So that's why your consumer goes down. Okay. So again, you cannot start reading the data from the beginning, right? Because you have already consumed so many things. Why you will consume the same data again and again? So that's why we are storing the position till where you have already read the data, and that thing is stored in the zookeeper. So by any chance, if there is any accident at the consumer side, whenever consumer comes up, it will first go to the zookeeper and it will tell, hey, please give me the last position till where I have already read. So it will give, yes, this was the last position till where you have already read the successfully. You can start from here. Yeah. Am I clear, Jagdish?
Yes. Yeah.
Of Kafka. This is how it all happens. Nothing rocket science in this. These 10 points are the backbone of your Kafka system. Okay.
Yeah.
If you have any questions, you can ask me. I'm giving you just 2 minutes to read these points once again, and then we will go to the next slide. Any questions?
No, sir. That's fine.
Shall we move ahead?
Yes, yes, sir.
Okay. There was one last point also. Consumer has the option to rewind, skip to the desired offset of a topic at any time, and read all the subsequent messages. So suppose while reading the data, if consumer feels like I don't want to read the data continuously, I need to directly subsequent messages. So suppose while reading the data, if consumer feels like I don't want to read the data continuously, I need to directly jump on to particular location. Okay, that is also possible.
Sorry, could you please repeat that? I didn't get it.
Yeah. So till now, till this previous point, we were reading the data sequentially. 0, 1, 2, 3, 4, 5. So consumer was reading like this in the sequence. But if you need the next data is not useful, you have read till 5. 1, 2, 3, 4, 5. Data number 6 and 7. These two are of no use. Then you can directly skip to data number 8. That is also possible. That's what it is mentioned here. Consumer has the option to rewind or skip. Rewind means you can go back also and you can jump forward also. Okay. Just consumer has to supply the offset number. Simple. So last time I read data number 6. Now I don't want to read 7. I will give directly 8. I will supply the offset 8 to the Kafka broker and it will give me the data. So everything is offset based. Whatever offset consumer is demanding, that data it will receive.
Okay.
So that
offset number we can design the way we can read it.
Yes.
Pick the data. Yeah.
Yes. Exactly. Right. So it's very simple. It's up to you. You are the consumer. No one can force you to read the data sequentially. No one can can force you to read the data only in forward direction. You can go backward also. If you are reading data number 4, after that you can specify offset number 2. So you can jump directly backward. And you can read the data number 2. So it is rewinding also and you can skip also. Anything is possible. Okay. Now your question would be in this, why we need this kind of jumping or why we need rewinding. So I can give you one scenario of rewinding. Suppose you have read some data that was read successfully when you were reading it, but somehow that data got lost at your end. You are the consumer. At your end, you are the consumer. You read the data, but you lost that data due to some of the other reasons. So you have to read it again. Correct?
Yeah.
So that is the scenario when you can rewind it. You can go back and you can read it again. Okay. And sometimes if you feel like some data you have already read by mistake, you are reading it again, then you can jump to any other location. So that is forward jumping, you can say. Simple. So this workflow was for publish and subscriber based messaging, which happens in Kafka. Now, second scenario was this workflow of queue messaging or consumer group. So that we will see. This we have already seen. I'll have to change this slide. I'll do that. Now, next thing is workflow of queue messaging or consumer group. What happens is producers send message to a topic in regular interval. This is same. Nothing special in this. Kafka stores all messages in partitions configured for that particular topic, similar to the earlier scenario. Very simple. Now, third point is where we will see the difference. A single consumer subscribes to a specific topic. Suppose the topic name is topic 01 and its group ID is group 1. Okay. So consumer group we have already understood. So if there are 3 consumer in a particular consumer group, first of all, consumer group has a group ID. You have to understand this. Each consumer group will have a group ID. Like how if you are studying in a particular branch, you will have a branch ID. Obviously, in your roll number, branch ID will be there. So similarly, if there are some 5-6 consumer and those consumers belong to the same consumer group, they will share a common group ID. Okay. So now you have two things: topic ID and group ID. Clear? So here topic ID is topic 01 and group ID is group 1. Now, Kafka interacts with the consumer as publish and subscribe messaging until new consumers subscribe to the same topic 01 with the same ID as group 1. So suppose I told you earlier, if there is one consumer, then there is no issue. There is no problem with who will read which partition. That is fine. But as soon as you get one more consumer in the same group, then the concept will change. Then we will see how both the consumer will read the partition. So once the new consumer arrives, Kafka switches its operation to share mode and shares the data between the two consumers. Okay. This sharing will go on until the number of consumers reach the number of partition. Comparing will happen, correct? Suppose if there are two topics, then what will happen? There is no sharing required. There are two partitions. Sorry, I said topic. So topic is one only. There are two partitions in that topic, and there are two consumers. Do we need any kind of sharing between the consumers? No, because one partition will be assigned to one consumer, second partition will be assigned to second consumer. No sharing is happening. Sharing in the sense, two partition will not go to the same consumer. Any doubt?
No.
Okay. Now, once the number of consumer exceeds the number of partitions, the number of consumer exceeds the number of partition. Okay. Once the number of consumer exceeds the number of partition, the new consumer will not receive any further messages until any one of the existing consumers unsubscribes. So this is very clear. I told you, number of consumers cannot be more than the number of the partition. Otherwise, that extra consumer will remain idle. Okay, and that will remain idle till the time any one of the subscriber goes down, or that subscriber or that consumer unsubscribes from the topic. Then only that idle consumer will participate in the consuming the message. So this scenario arises because each consumer in Kafka will be assigned a minimum of one partition, and once all partitions are assigned to the existing consumers, the new consumer will have to wait. Existing consumers, the new consumer will have to wait. Clear?
Okay.
Next point. This feature is also called consumer group. We have understood. So you call it either queue messaging, or you can call it consumer group messaging, whatever you want to call it. Why we are calling it queue messaging? Because consumer will have to consume the messages only when they come first. Any consumer which is joining the group, and if it is more than the number of partition, then that consumer will never be able to read the message, because partitions, all the partitions are busy. All the partitions are assigned to consumers. Next, Kafka will provide the best of the both system in very simple and efficient manner. So this is also very clear that in this way, what will happen? You can easily utilize the full capacity of the Kafka partitions, right? So any doubt in these 7 points, you can read again and let me know.
Okay. In the sixth point, it is possible to have an additional consumers than the then the partition, but it will remain idle. Once any consumer is not working, then this consumer will come into play. Okay.
Yes, we can have it, but it's not a intelligent idea. Who will waste the consumer if it is not in use? Generally, consumer never goes down. Hardly any consumer goes down. So just for the backup purpose, no one will invest in extra consumer, right? That will just wastage of money. But if you want, you can add unnecessary consumers. It's your wish. Like no one is stopping. Any other question?
No.
Okay. So Zookeeper we have understood. There was one box which was in the middle and in the bottom. So that was called Zookeeper, and we have already discussed. So I'm just again repeating in detail what is the role. It is a distributed configuration and synchronization service. So basically it performs the coordination between brokers, and it also tells about the current status of the Kafka cluster. How many brokers are there? Whenever a new broker joins, that also will be published. So that is the purpose. Second point is serves as the coordination interface between the Kafka brokers and consumers. Okay, so consumer if it want to communicate with any broker to read the data, it will go via the Zookeeper only, because consumer doesn't know anything about the Kafka cluster. So consumer has to get all the detail from about the Kafka cluster. So consumer has to get all the detail from the broker only. How many brokers are there? Where my partition? Where is my leader partition in this Kafka cluster so that I can read the data? Okay. Third point is the Kafka servers share information via Zookeeper cluster. So one server, one Kafka broker want to inform about itself to the other broker. So it has to inform to the Zookeeper, and Zookeeper will inform to everyone. Okay, that's how all the Kafka brokers in the cluster will come to know about each other, because these Kafka machines are located at different places. They are not in the single room or single office building. Kafka brokers can be anywhere. One broker is in one country, second broker in the some other country, right? Is in one country, second broker in the some other country, right? That is possible. So definitely they are at very much distance. They are at different geographical location. So they will coordinate with Zookeeper to inform about themselves to the other brokers. Now, last point is Kafka stores basic metadata in Zookeeper, such as the information about topics, brokers, consumer offsets, and so on. So I think all these points we have already discussed, just that I have summarized them here one more time. So that is all for today. So the focus of today's discussion was to tell you what is consumer group and two types of. So obviously publish subscribe messaging will be used when there is a live streaming. Okay, because we need the live data. We cannot simply put the data in Kafka and that data will be read after 2 days. No. Second approach will be used when data can be consumed anytime. 1 day after, or 2 days after, or after 1 week. So it will be stored in the partition, and then whatever consumer comes first, those will be allocated with the partition and they will start reading the data. If the consumer IDs of two consumers are same, then definitely they are part of the same consumer group and they cannot read the same partition. Okay. So then definitely they are part of the same consumer group and they cannot read the same partition. Okay. So the very basic question is how you will identify these two consumers are from the same consumer group. So your answer will be, there will be a consumer ID, consumer group ID. So using that consumer group ID, Kafka cluster will identify whether those two consumers are from the same consumer group or from different consumer group. If they are from the same consumer group, they cannot read the same partition. Okay. Any question in this? Okay. So you have the laptop
Yes.
with Java and everything.
No, Java I don't have.
Java you don't have. Okay.
It's my personal laptop. I don't have any.
Yeah, that's fine. But it has good configuration. Like we can install Kafka in that, like RAM and all.
Yes. Yeah, it's good only. Like
Okay.
SSD.
Yeah. Anyway, it won't take much.
RAM.
Yeah, it won't take much capacity. Just like that, I'm asking. It should be fast enough so that it's not stuck.
No, it's